Reactions of benzoic acid. This is today's lesson. In this lesson, we are going to learn electrophilic substitution reactions of benzoic acid. So let's get started. Benzoic acid. This can be written in this way. Carboxyl group. Carboxyl group acts as benzene ring deactivating group. Carboxyl group reduces activity of benzene ring towards electrophile. Carboxyl group acts as meta-directing group towards electrophile, and this is showed through some resonance structures. Resonance structures are formed which is started from carbonyl group. Here, electronegativity of oxygen is 3.5. Electronegativity of carbon is 2.5. We get resonance structures and source is carbonyl group. As electronegativity of oxygen is higher than carbon, this carbon-oxygen bond gets polarized, and at that time over carbon positivity develops. That is why this pi bond moves here, and this is obtained. Carbon-carbon single bond turns into carbon-carbon double bond. Carbon-oxygen double bond turns into carbon-oxygen single bond. Here, negative charge. When this pi bond moves here, this carbon, ortho carbon, becomes positive in charge. Here double bond, here double bond. Then this pi bond moves here, and this is obtained. Here double bond, here double bond. Now paracarbon becomes positive in charge. Then this pi bond moves here, and this is obtained. Here double bond, here double bond. This orthocarbon becomes positive in charge. Now, because of this positive charge, these electrons move here. This pi bond moves here. Finally, this is obtained. Carbon-carbon single bond, oxygen, hydrogen. Again carbon-carbon double bond. Here double bond, double bond, double bond. Again, these structures are obtained. Resonance hybrid is, this can be showed simply. Carbon-oxygen partial double bond. This oxygen is partially negative in charge. This carbon is partially positive in charge. Orthocarbon. This orthocarbon becomes partially positive in charge, and this paracarbon becomes partially positive in charge. That is orthocarbon, paracarbon, orthocarbon. These may be the resonance hybrid of benzoic acid. Simply, this can be showed as resonance hybrid, in which orthocarbons and paracarbon become positive in charge, partially positive in charge. So, comparatively, metacarbon becomes responsive or susceptible towards electrophile. So, electrophile attacks metacarbon because metacarbon is comparatively responsive towards electrophile than orthocarbons and paracarbon, because orthocarbons and paracarbon are partially positive in charge. So, electrophile simply attacks metacarbon. When electrophile attacks metacarbon, then this is obtained benzoic acid, sigma complex is formed, hydrogen, electrophile. Because of this positive charge, this carbon hydrogen bonding electrons move here, and as a result, meta substituted product is obtained, and this hydrogen gets freed as electrophile. That is, electrophilic substitution occurs. In this lesson, we are going to learn electrophilic substitution reactions of benzoic acid. Now let us see some reactions. Benzoic acid, in which carboxyl group is a kind of electron withdrawing group. As carboxyl group is electron withdrawing group, carboxyl group deactivates benzene ring. Carboxyl group is a kind of meta-directing group. When benzoic acid is treated with halogen, suppose chlorine, in presence of iron powder, and the reaction is conducted by heating, from chlorine, chloronium ion or chlorine cation is formed as electrophile that attacks metacarbon, and from this metacarbon the hydrogen present here gets released as electrophile. That is, electrophilic substitution occurs at meta position, and as a result, this is obtained metachlorobenzoic acid. Hydrogen released from benzene as proton that combines with chloride ion, which is produced from chlorine molecule, and hydrogen chloride is formed. So, metachlorobenzoic acid is formed when benzoic acid is treated with chlorine in presence of iron powder. Next, when benzoic acid is nitrated, that is concentrated nitric acid, HNO3, in presence of concentrated sulfuric acid. Here, concentrated nitric acid forms nitronium ion as electrophile in presence of concentrated sulfuric acid. This nitronium ion attacks meta position, and as a result, this compound is formed meta-nitrobenzoic acid or 3-nitrobenzoic acid with respect to carboxyl group. This is metachlorobenzoic acid or 3-chlorobenzoic acid. This is position number 3 with respect to carboxyl group. Now, when benzoic acid is treated with fuming sulfuric acid, that is, now benzoic acid undergoes sulfonation. Fuming sulfuric acid produces neutral electrophile sulfur trioxide that ultimately converts to sulfonic acid group. Now, this neutral electrophile sulfur trioxide attacks metaposition to form this product, sulfur trioxide, that ultimately changes to sulfonic acid group. Here, byproduct is water. In this case as well, byproduct is water. Now, this is the product. Its name is metasulfobenzoic acid. That is to say, metasulfobenzoic acid is formed when benzoic acid is sulfonated. Benzoic acid is treated with fuming sulfuric acid. Then metasulfobenzoic acid is formed. That is, here as well, electrophilic substitution occurs. These are the reactions of benzoic acid. Electrophilic substitution reactions of benzoic acid. No more today. Thank you very much.